Today we're going to be doing AP Calculus 3.6 and I'll be trying to guide you through how to do optimization problems. So first we're given a question that asks us to determine the dimensions of a rectangular field with the minimum amount of fencing, and this rectangular field, it encloses 441 feet. So what that looks like is we have a rectangular field here and the area of this is 441 feet squared. So A equals 441. And we have to determine the dimensions of a field which has the minimum amount of fencing. So first we should label our field, and the area of a field, the area of a rectangle is just length times width, so we can label that as like x and y here. And remember that because the area of a rectangle is just length times width, the area of this is just x times y, and our area here is 441. So 441 equals x times y. And because we're doing an optimization problem, we need to solve for one variable. So just getting y alone, for example, we would just divide by x. So y equals 441 over x, and this is our constraint for the area, right? So now what this is saying is that it basically wants us to optimize the perimeter, and the perimeter of a rectangle is 2x plus 2y, but here we have our y is 441 over x, so we can just plug that in. And to solve for a minimum amount, we want to take the derivative of this first. So cleaning this up, this just looks like 2x plus 882 times x to the negative 1. So doing p prime, you'd get 2 plus 2 minus 882 x to the negative 2. And that just looks like 2 minus 882 over x squared. Okay, so now that we have p prime equals 2 minus 882 over x squared, we have to solve for the critical points now to find the minimum. So just moving this to the other side, you get 2 equals 882 over x squared, and then multiplying both sides by x squared, you get 2x squared equals 882. And dividing by 2, you get x squared equals 441. So that means that x would be equal to plus or minus square root of 21. I mean, square 21, just 21. And we can ignore the negative because we don't need a value, so we can't have a negative value, so it would just be x equals 21. So now solving for our critical points, with our critical points, we can see if we have a minimum, right? So this would be 21, and plugging in values less than 21, it give you a negative value, and then values over 21, it give you positive. So what that looks like is negative, positive, and you have a minimum right there. So now we know our x value, but remember from earlier, our y was equal to 441 over x, and we have our x, so y equals 441 over 21. And that's just equal to 21. So our rectangle, our x, 21 feet, and then our y, 21 feet, and that's going to result in a minimum amount of fencing that encloses 441 feet. Okay, now we're given this question where it says find a positive number such that the sum of 7 times the number and 175 times its reciprocal is as small as possible. So it gives us this, a positive number, and it has to be that its sum, so it's going to be an addition problem. So 7 times the number, we can call this number x, 7x, and plus something, 175 times its reciprocal. So remember a reciprocal, for example, if you have something like 8, its reciprocal would be 1 over 8. So here, 7x plus 175 times its reciprocal, so it'd be 175 times 1 over x, and we're asked to find a minimum value. So this has to be as small as possible. So first, you want to do the derivative of it, and if you rewrite this, it's just 7x plus 175 times x to the negative 1. So doing the derivative of that equation, you'd get 7 plus 7 minus 175 and then x to the negative 2, or 7 minus 175 over x squared. So now we have our y prime, and we want to solve for the critical point, so we would just do 7 equals 175 over x squared, and moving the x squared to the other side, you get 7x squared equals 175, and 175 divided by 7 is 25, so x squared equals 25, and x would equal plus or minus 5. Right, but remember that it's asking for a positive number, so we only need x equals 5. And if you want to test that on the number line, you can. At 5, you would have a negative value before 5, and then after 5 you'd have a positive value, which results in a minimum. So x equals 5. Okay, again we're given another problem where it gives us a rectangular field that encloses 256 yards, so its area is 256 yards squared, and we have to determine the dimensions of the field that will require the minimum amount of fencing. So our area equals 256, and remember that area is just x times y, so 256 equals x, y, and solving to get y by itself, you get y equals 256 over x. So now remember that perimeter is 2y plus 2x, so here p equals 2x plus 2y, and that's 256 over x. Right, so now simplifying that out, you get 2x plus 512 and x to the negative 1. And doing the derivative of perimeter, you'd get 2 plus 2 minus 512 and then x to the negative 2, or 2 minus 512 over x squared. So solving that for 0 to find your critical points, you'd get 2 equals 512 over x squared, and then 2x squared is equal to 512, or x squared is equal to 256. So the square root of 256 is 16. So x equals plus or minus 16, but we can ignore our negative value here, so we would just end up with 16 as our critical point. Now on a number line, if you wanted to plot it, 16 would be right here, and numbers before 16 would be negative. Numbers plugged in after 16 would be positive, resulting in a minimum. So now that we have x equals 16, we can plug it back in here to solve for our y. So y equals 256 over x, and our x is 16, so y would equal 16. So the minimum dimensions that encloses 256 yards would be 16 by 16 yards. Okay, so now we're given a question where it says find the area of the rectangle of the largest area that has its base on the x-axis and its two other vertices above the x-axis and lying on the parabola of y equals negative 6x squared plus 450. So that's a bunch of stuff, but what it basically looks like is that you have a parabola, y equals negative 6x squared plus 450. You have a parabola that looks like this, and there's a rectangle inside of it that is the maximum possible rectangle, the largest possible rectangle, and we have to find the area of this rectangle. So remember the area of a rectangle is just x times y, but here we have x and we have x again on both sides, and our height is y. So our area is 2x times y. Our area of the rectangle is 2x times y. And here it says that y equals negative 6x squared plus 450. So our area is 2x, and instead of writing y, we can write negative 6x squared plus 450. And simplifying that out, you get a equals negative 12x to the third plus 900x. And now with that, we can do the derivative of a. So a prime would be equal to negative 36x squared plus 900. Right, so now we have to find the critical points of a prime. So we would just have 36x squared equals 900, and 900 divided by 36 is 25. So x squared equals 25, meaning that x equals plus or minus 5, but we can ignore our negative value, so x would just equal 5. Now we have our x value, 5 right here, 5 right here. So now we have to just plug that in for y. So a equals 2 times 5, and solving for y, our y equals negative 6, and instead of writing x, we can write 5 squared plus 450. And that is y equals negative 150 plus 450, so our y equals 300. And a equals 2 times x, which is 5, times y, which is 300, and that gives us an area of squared. Okay, so now we're at being asked to find a point on the line 2x plus y equals 10 that is closest to the point 3, 9. So basically it just wants us to find a point, say 3, 9 is like right here or something, and it wants us to find a point on the function that is closest to it. So to do that, first write down 2x plus y equals 10. That's our line. And we have to find the point closest to 3, 9. So first step is to solve for y to get y alone. And moving 2x to the other side, you get y equals 10 minus 2x. So now we have our y, and we're trying to find a point x comma y. That's going to be our answer right here. That is closest to 3, 9. So to do this, we have to use the distance formula that states d equals square root of everything x2 minus x1 squared plus y2 minus y1 squared. So we can label this as our x2 here and our y2 here, and this would be our x1 and our y1. So what the distance formula for this would look like is just x minus 3 squared plus y minus 9 squared. And remember that from earlier, our y is 10 minus 2x. So d squared, to get rid of the square root, d squared would just be equal to x minus 3 squared plus 10 minus 2x minus 9, or squared, and then you can just do 1 minus 2x. So now we can say, we can just improvise another variable for d squared. Let's say f, so f equals d squared. Let's say f equals this. So we have to find f prime, do a chain rule, move the 2 to the front, 2 times x minus 3 plus, and then move this to the front again, plus 2 to the 1 minus 2x to the first power, but remember, multiply by the inside derivative, so it'd be times negative 2 again. So now simplifying that out, you'd get f prime equals 2x minus 6, and we can simplify this and this to like negative 4, so plus 4 plus, so plus negative 4 times 1 would be minus 4, and then negative 4 times negative 2x would be plus 8x, and that is equal to 10x minus 10, or in other words, f prime equals 10x minus 10. So now finding our critical points of f prime, we would just set it to 0, so 10x equals 10, x would equal 1. So now we have the first part of our equation. We have the x value, which is 1, so we'll just put 1 right here, and now we just need to find the y, and which we already have. So y equals 10 minus 2x, or y equals 10 minus 2 times 1, y equals 8. So that would be our answer. Again, another problem. A point on the line x plus y equals 8. And we have to find a point closest to negative 1 comma 1. So first, let's get y by itself. Y would equal 8 minus x. And we're trying to find x comma y closest to negative 1, 1. And this is x2, this is x1, this is y2, and this is y1. So now using the distance formula, we have d squared equals x plus 1 squared plus y minus 1 squared. And substituting for y, you'd get x plus 1 squared plus 8 minus x plus 1. No, minus 1, sorry. And then squared, and that's equal to 7 minus x squared. So now, let's set d squared equal to f. So our f prime, doing the chain rule, it'd be 2 times x plus 1 plus 2 times 7 minus x, and then multiply that by the derivative of negative x, which is negative 1. So we can actually just put negative 2 right here, because negative 1 times 2 is just negative 2. So our f prime is equal to 2x plus 2 minus 14 plus 2x. So simplifying that out, you get 4x minus 12. And solving for the critical numbers, 4x equals 12, so x would equal 3. And with x equals 3 right here, you just plug in y equals 8 minus 3, and y equals, meaning that y would equal 5. So point 3 comma 5 would be the best point. Alright, so now we're given a kind of weird problem where we have a cylinder, and this cylinder, it has an open top, and the volume of this cylinder is 2,338 inches cubed, and we have to find the radius r and height h of the cylinder to minimize the material used, or in this case to minimize the surface area. So first, they give us the surface area of a cylinder is 2 pi r squared plus 2 pi rh, and because this cylinder has an open top, that means that we get rid of this 2 right there, right? And they also give us the volume. So let's label this as just our surface area. So, and they give us our volume as well. So pi r squared h, and we want to solve for one variable, and let's solve for h so we can plug it in. So h in this case would be equal to v over pi r squared. So now we have s equals pi r squared plus 2 pi times r times h, which is v over pi r squared. Now if we look right here, we have v, but remember that v is 2,338. So that's our v. So h equals 2,338 over pi r squared. And simplifying this out, the pi r here cancels with 1 pi r there, so we get s equals pi r squared plus 2 times 2 times 338 which is 4676, and that would look like this: 4676, 2 times that, and then 1 pi r cancels. So that's what our equation for the surface area would look like. Okay, but notice how we have a pi here. We shouldn't have a pi there because the pi's, when you multiply them, they cancel. So you're left only with 1r. So now with that information, we can do the derivative of surface area in terms of only r. So that would be 2 pi r plus 4676 over r squared. And now solving for that for 0, solving that for 0, 2 pi r, you can write that would be equal to 4676 negative over r squared. And if you multiply both sides by r squared and r squared over here, you're gonna get 2 pi r cubed equals negative 4676, and just divide by 2 pi, divide by 2 pi, you're gonna get r cubed equals negative 4676 over 2 pi, or r equals the cube root of this. So now we can write that in our calculator here. Cube root of negative 4676 over 2 pi. So our r is equal to, not just moving some stuff, our r would be equal to negative 9.0610621 562. Yep, that's our r. And remember that we have our h. I just removed it, but we have our h that we got earlier in terms of r, and that's right here. So h equals 2338 over pi times this squared pi r squared, and just putting that in for the calculator, 2338 times pi, and then this squared, negative 9.0621562, and we're given that. So, oh, and this shouldn't be negative, so it would be 9.062 for both of them. Okay, now we're given a question where we have a piece of wire that is 64 centimeters long, is cut into 2 pieces. So one piece is going to be made to form an equilateral triangle, like this, and the other will be made to form a circle, like that. So now we have to find the lengths of the 2 pieces that cause the sum of these 2 areas, so area here plus area here, to be at a minimum. Right, so here we have a wire that's 64 centimeters long, so our first side would be x, our second side would be 64 minus x in order to account for the whole length. So for an equilateral triangle, it has 3 sides, right? It has B, B, and B. So what that means is that 3b is going to equal x, Alright, so b, one side here, b is a side, just one side b, we can call our side b here. So 1b would be equal to x over 3, because 3b's is equal to x. Alright, and a circumference of a circle is 2 pi r. That's our circumference. So we have to find that in terms of r. So 2 pi r equals 64 minus x, because that's what's being used to make the circle. So now solving that in terms of r, you have r equals 64 minus x over 2 pi. So now we have our two variables, or our two side lengths, and with that we can find the area first of a equilateral triangle. The area of an equilateral triangle is root 3 over 4 times this stuff times b, right? So, but now we have b equals x over 3, so our area of both is equal to this first, root 3 over 4 times b. That's the area of an equilateral triangle, but our b is x over 3, so we can just write that. X over 3 squared, sorry. And then plus, because we're doing the sum of these two. And the area of a circle is pi r squared, so we'd write pi r, no, pi, and then this squared, so 64 minus x over 2 pi squared. So now, just simplifying that out, you'd get a equals x squared, so root 3 times x squared over 9 times 4, which is 36, plus this, pi 64 minus x over 2 pi squared. And now doing the derivative of this a prime, you'd move the 2 to the front, so 2, it could cancel with the 36, you get root 3 times x over 18, because 36 divided by 2 is 18, plus 2 pi times, keep this, 64 minus x over 2 pi, and then the derivative of the inside is just derivative of this would just be equal to negative 1 over 2 pi. So negative 1 over 2 pi. And now we solve for our critical points. So now that we have a prime, we can solve for 0 first, cancel out the 2 pi's here. Alright, so root 3x over 18, and then times negative 1, so it would be minus 64 minus x over 2 pi. And we have to solve that to equal 0. Right, so we can just set them equal to 0, and that would be the same thing as setting it equal to each other. So to find our values, we can do cross multiplying. So 2 pi times root 3 times x is equal to 18 times 64 minus x, and 18 times 64 is that, so 1152 minus 18x is just equal to 2 root 3 pi x. And moving our x's to one side, we'd get 2 root 3 pi x minus plus 18x is equal to 1152. So now, taking an x out of all of that, we'd get 2 root 3 pi plus 18 is equal to 1152. And right here, if you do that, 1152 over 2 times the square root of 3 times pi plus 18. So now our x equals 39.88853.349. So now we have this value here. So plugging in this 64 minus that, 64 minus 39.8853.349, it'd be 24.1146651. So now we have both our values, and rounding it to 3 decimals would be 39.885 and 24.115. Okay, so now we're given a question that says a cardboard box that is 24 by 45 is formed into an open top box by cutting squares with side length y from each corner, and we have to define the dimensions of the box that maximize the volume of the box. So it might be weird, but what that kind of looks like is like this. This is like kind of how you make a box, and what it's saying is that each length here is y, 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 all the way around, and then the length here is 45 inches, and the length here is 24. So we have to find the length times the width times the height. That is the maximum, right? So our length would be 45 if we didn't have these two y's right here and right here that are making our length shorter. So basically, since these two y's are making our length shorter, it'd be 45 minus 2y, that's our length. And same thing for the width right here, it'd be 24 minus 2y equals our width, and then our height is just y. So now we can find the volume, right? So V equals this times this times this, so 45 minus 2y times 24 minus 2y times just y. And if we solve that and simplify that, 45 minus 2y times 24 minus 2y times y, we're left with v equals 4y cubed minus 138 y squared plus 1080 y. And now with that information, we can find the derivative of v and then solve for those critical points to find the values. So v prime would be equal to 12y cubed minus 138 times 2, which is 276, y plus 1080. And if you solve that for 0, you'd get y equals 18 and y equals 5. So those would be our critical points. Y equals 18 and 5. Now, here we can plug in. First, let's try plugging in 18 to, say, the width, right? 24 minus 2 times 18. Now, if you plug in 24 minus 2 times 18, you'd get a negative number. So that doesn't work. So that means we should probably be using 5 for our y to plug in here. So length 45 minus 2 times 5 is just 45 minus 10 equals 35. And then 24 minus 2y, 24 minus 10 equals 14. And then our y is just 5. So our answer would be 35 by 14 by 5. Okay, so now we're given this question where we have an island that is 4 kilometers south of a point P right here, and there's a town 10 kilometers east of the point P, and this person, Marquez, he can run at a rate of 8 kilometers per hour, and he can ride a boat at a rate of 7 kilometers per hour. So to get to this island here, he first has to run this distance, and then he has to take a boat this distance to complete the trip. So now we have to find out how to minimize the time that it will take to get from the town here to the island, and we're asked to find the distance that he needs to cover by boat. So what this looks like is that there's a town right here and an island right here, and this person Marquez, he first has to run this way, and then he takes a boat this way to get to the island. So here we have the island, and we have our starting point, and this distance, this is 10, and this right here is P, and this is the distance he's going to travel by boat. So to split these up, it's x here and 10 minus x, and this is our distance. We can call it like y, and here it's 4. So what that looks like is basically the Pythagorean theorem. Remember, this side squared plus this side squared equals this side squared. So we can just write it here, x squared plus 4 squared equals y squared. And just solving for that, we get x squared plus 16 equals y squared. And to get everything, to solve for y, to get y by itself, we can just take a square root of everything. So y would equal the square root of x squared plus 16. So that's just solving for our Pythagorean theorem, our constraint equation. So now we can look at the speeds that he's running, and remember that time is equal to distance over speed, and we have two distances here. We have 10 over x, which is the distance that he's running at 8 kilometers per hour, and we have a distance right here, y, which he is riding a boat at 7 kilometers per hour. So if time is distance over speed, that means we have to take the times of both of these intervals, which means that time would be equal to distance over speed here and distance over speed here. So our distance over speed for the first part, which is what he's running, would be 10 over 10 minus x, because that's the distance that he's running, and then over speed, which is 8 kilometers per hour. So 10 minus x over 8, and now we add that. That's in addition to the distance over speed of the boat, and the distance is y over 7 kilometers per hour, which is what he's running. But remember that we just solved for y here with the Pythagorean theorem, so we can write it again. T equals 10 minus x over 8. And instead of writing y, we can write x squared plus 16 square root over 7. Now, what we can do with this equation is that we can find the critical points in order to find the minimum. So let's do that. T prime equals 10 minus x over 8. So this is just 10 minus x times 1 over 8. And the derivative of 10 minus x is just negative 1 times 1 over 8. That's just negative 1 over 8. So now square root of, derivative of this, we can do x squared plus 16 square root, and that's going to equal 1 over 2 root x times the inside derivative, so 1 over 2 x squared plus 16 times 2x, because that's the derivative of 2x, and these cancel, but remember that everything is over 7, so it's times 1 over 7. So our t prime, how we're going to solve for the critical points, is negative 1 over 8 plus 1/7 times x over x squared plus 16. And now we solve for the critical points. Okay, so now that we have our t prime, we can solve for the critical points. So we set this equal to 0, and we can write it like x over 7 times square root of x squared plus 16 is equal to 1 over 8. And to solve for 0, we can cross multiply, so 8x is equal to 7 square root of x squared plus 16. And now we can square everything and square everything to get rid of that square root. So we'd get 64 x squared is equal to 49 times x squared plus 16. And if we just simplify that out, we get 64 x squared is equal to 49 x squared plus 784. And if we move the x squares to one side, we get 15 x squared is equal to 784. And square root of 784 over 15 is equal to 7 point x equals plus or minus 7.22956.891. And now we have our x value, but remember that the distance we're trying to find is y, which is the distance that he's riding the boat, but we already have our y, which is right here. Y equals square root of x squared plus 16, and we have our x as well, so we can just do square root of this plus 16. So y equals 7.22956.891 plus 16 to the square root. And then that looks like is just 7.22956.891 squared, because it's x squared, plus 16. And our answer for y should be 8.262 kilometers. Okay, so now we're given a question where we have to construct a box with base length that is 3 times base width, and we're given material. To build the top and bottom, it costs $4 per feet squared, and to build the sides, it costs $2 per feet squared. And this box must have a volume of 6,561 feet squared. And we must determine the dimensions that will minimize the cost to build the box. So what we have is that we have like a rectangular box, kind of like this, sort of like this. And this rectangular box, our length of it is 3x, our width of it is just 1x, and we can call our height something like y. So remember that a volume of a box is just length times width times height, so we have 3x. So we have 3x squared times y is equal to our volume, but remember that our volume is 6,561. So now with that information we can solve to get y alone. So y would be equal to 6,561 over 3x squared. So now that we have our y, we have to now go back to our box and notice how we have the area, right? We have to find area now of each side. So we have 4 sides in total, right? And then we have one top and one bottom. So for our 2 longer sides, right here and right here, it would be 3x times y to find the area of those sides. And then to find the shorter sides right here and right here, it would just be x times y. And then for our top and bottom, it would be y times, no, it would be, yeah, it would be x times our length here, 3x, to find the top and bottom sides area. So our area is equal to 3x times x, so 3x squared, and then plus that to, or the area of all the sides, 3x squared plus, and then 2 of them are going to be 3x times y, and 2 of them are going to be x times y, so 3xy times 2, and then x times y twice, so 2xy, so 2xy, and in total it'd be, you'd have 6 xy's here, 2 xy's here, so 3x squared plus 8xy. And now that we have these values, we can do our cost function. But so it'd be $4 for the top and bottom, which is this. So 4 times 3x squared is 12x squared, and then 8 times 2 to build the sides, plus 2 times 8, so 16xy. And now we can plug in our y from earlier, so c would equal 12x squared plus 16 over 3x squared. 16x times that, so 16x times 6,561 over 3x squared. You can see that one x cancels with one x, and then it's 16 times 6,561, so 10,000 or 100,000, and then all of that would be over 3, so 34,992 over x. So 12x squared plus 34,992 over x, and that's equal to our cost function. And now we can do the derivative of that, so c prime would be equal to 24x plus, and this is negative, so it'd be negative just 34,992 over x squared. And now we can solve for our critical points. So it turns out I made a mistake in this part of the question, but it's okay because it's just that I forgot one little thing. It was that 3x squared, right, is the area of one top or the area of one bottom of this triangle. I mean, rectangle. I mean, whatever it's called. And then we have two top and bottom, so that means we have two 3x squareds, which means that right there it's actually 6x squared, and then everything after that replace it with 6. So 6x squared, instead of having 12x squared, you'd have 24, and then here it'd be 24, and then here it'd be 24, and then doing the derivative it'd be 48. Right, so now that we have our c prime function, we can find the critical points by setting it equal to 0. So 48x, not 24x, it'd be equal to 3,992, 34,992 equal to x squared, and moving the x squared to the other side, you get 48x to the third equals 34,992, and 34,992 divided by 48 is 729, and doing the cube root of that, of 729, you get x equals 9. So that's our x value right here. And to find our dimensions, we can just plug in. So length times width times height. This is our width, x equals 9. So our length would be 3 times 9, or 27. And our y, we have this here, 6,561 over 3 times 9 squared, which is 81. Or 27. So our thing here, it'd be 27 by 9 by 27. Okay, and now we're given a question where we construct a box with a square base. So we just have a normal square. Now it's like a box. And because it's a square, its length is going to be x, its width is going to be x, and its height is going to be y. And the top and bottoms, they cost $7. And the material used to build the sides, they cost $5. And this box has a volume of 175 feet cubed. So we can find our volume first by doing length times width times height. So x times y is x squared times y is equal to our volume, which is 175. And getting y by itself, y is equal to 175 over x squared. So now that we have y, we need to find the area of each side. So we have a square, so it's just going to be 4 equal length sides. So it'd be our area of the sides, it would just be x times x 4 times. No, it'd be x times y 4 times, because that's y is the height and x the side. So 4xy, and then for the top and bottom, it'd be 2x times x's, because you have one top and one bottom. So what that looks like is 2x squared for both the top and bottom, plus 4xy for all four sides. And now for our cost function, each top and bottom costs $7. So 7 times 2 is 14, 14x squared, plus the sides cost $5, so 5 times 4, 20xy. And plugging in y, we get c equals 14x squared plus 20x times 175 over x squared. And simplifying that out, we get 175 times 20, so 3,500 over x. Right, so now that we have our cost function, we can do the derivative of the cost function. So c prime, it'd be equal to 28x plus or minus 3,500 over x squared. And setting that equal to 0, we get 28x is equal to 3,500 over x squared, or in other words, 28x to the third is equal to 3,500, and 3,500 divided by 28 is 125. So x to the third equals 125, and the cube root of 125 should just be 5. So our x's right here, they cost 5. I mean, their length is going to be, x is going to be 5. It's going to be 5 that way. So now that we have our x value, we can just plug in to our cost function, right? So c cost is equal to 14 times 5 squared plus 3,500 over 5. And that's equal to $1,050. Alright, thank you for joining me for optimization